All right, this is a really long reading. Neutralization of acidic solutions, a lot of reading, some equations, more reading, more equations, more reading. The question, a student mixes the following pairs of compounds in solution. What is predicted to occur in each case? I have to tell you, I have no idea. This means nothing to me. And look at all the reading that we have to do. So if you come across a question like this on the test where there's a lot of information and it doesn't really make sense when you first look at it, what I want you to do is mark an answer, any answer, and then flag the test question. Come back to it if you have time at the end. Otherwise, do not waste time with it for now. You're not going to get 100% on this test, and that's perfectly okay. So anytime you get something like this where it's just going to be too much work, mark an answer, flag the problem, and keep going. All right, because we have a little bit of time, I'm going to try to do this. Coming up here, and we know that we're talking about the neutralization of acidic solutions. And when we look at the answers, no neutral, no neutral, neutral. Ooh, they put 2 in there. Yikes. And then B, neutral, neutral, neutral. C, no, no, no. D, neutral, neutral, no, neutral. All right. And we are looking for something that tells us whether it neutralizes or not. So we're going to come up here and read. Acids are compounds that ionize to form hydrogen ions. The concentration of hydrogen in solution is used to measure the acidity of a solution. So hydrogen apparently helps us determine if it's acidic. The greater the hydrogen concentration, the more acidic the solution. And then these two are acids. Their ionization reactions are shown below. So those are the two that they gave us, and this is what happens when they react. And interestingly, the H's separate out. So we'll see if that helps us. Bases are compounds that can react with hydrogen ions to reduce the concentration in solution. Bases can therefore neutralize acidic solutions. An example of a base is NaOH. When that is mixed with an acid, OH combines with H from the acid to form water. The overall equation showing the reaction of NaOH and hydrochloric acid and a general reaction scheme are shown below. All right, so this all happens. Here's our acid, here's our base. They were combined. We ended up with water and salt. So that neutralized. Water and salt are not acidic. So basically what I'm getting so far is if you mix something that's acidic with a base, it will be neutralized. The acid will not be an acid. Think in terms of lemons. Lemons are very acidic. If you've ever had straight lemon juice from a fresh lemon, it kind of burns your throat. And it may even upset your stomach a little bit. It's a lot of acid. But if you mixed it with water and sugar and made lemonade, it's delicious and it doesn't burn. So you have neutralized the lemon by adding water and sugar. All right, here, notice that the water is one product of the reaction and salt is another. These reactions are called neutralization reactions because both H and OH are lowered as a result. All right, let's see if we can figure this out. So neutralized H and OH. This is not really clear. And we don't have full equations. A student mixes the following pairs of compounds in solution. What is predicted to occur in each case? So if we've got KOH and NaOH, this is going to be a base and a base. So there's nothing to neutralize. I don't know if this is clear. This is kind of a guessing game. And this is why I say, if you get a problem like this where you're just not sure, mark an answer, flag it, come back to it later if you have time. But I'm going to say that this one, there's nothing to neutralize. There's no acid. So we come down here to HL or HI and KBr. I'm going to assume that both of these are acids because they do not have the OH, because it did say up here, OH lent itself to be a base. So I'm going to say nothing happens here either. This is two bases. The second one is two acids. Nothing is going to be neutral. There's nothing combining to soften one. And then we're looking at H2SO4, which is likely an acid, plus KOH, which is likely a base. So looking at the answers, I'm going to say nothing happens here, nothing happens here, maybe something happens here. We look at A, we've got no, no, yes. And we kind of said no, no, maybe. We look at B, yes, yes, yes. We already said no, no. B is out. C, no, no, no. We said no, no, maybe. C is out. Yes, yes, no. We already said no, no. D is out. It has to be A. So this is not at all easy, and it's very difficult to understand. And when you are under stress taking the test, this is still not going to make, it's going to make less sense than it would if you had 20 minutes to work on it as a homework assignment. So if you come across this or something like it, and you just feel like, you know what, this is going to take me far too long to decipher, mark an answer, flag it, move on. All right, let's take a look at, oh, whoops, here's another one. A scientist prepares two solutions using equal number of molecules of HCl and H2SO4. She can predict that the HL solution will be half as acidic as the H2SO4 solution, exactly as acidic, twice as acidic, or 3 times as acidic. I have to tell you, I have no idea. She can predict that the HCl will be half as acidic, exactly, twice, 3 times. This is really one that you are going to take a guess on. At least me, I'm going to take a guess on it. Yeah, I have absolutely no idea. I know what the right answer is, but I have no idea how they get there. The answer is A, but I don't see what would make me think that. Oh, yes, I do. Yes, I do. Yes, I do. Hydrogen is the element throughout all of this. All of the reading, we're back to the hydrogen ions. They can make it an acid, they can make it a base. So if we're looking at HCl, I'm not going to worry about the Cl. I'm not going to worry about the SO4. I'm going to only look at the H's. We've got 1H to 2H. The question is, she can predict that the 1 will be half as acidic. Exactly, it's not exactly, it's 1 to 2. Twice as acidic. No, because the H2 is higher. 3 times, no, it has to be A. Half, because 1, 2. That's a tough one. That took a long time. And you don't have a long time to spend. So just if you get questions like that, pick one, don't worry about it, flag it, come back if you have time. All right, Pressure and solubility. Big paragraph. Let's look at the question. We've got a nice little image. Gas molecules are the open circles. Liquid molecules have a little gray line in them. Based on the diagram, what outcome can be predicted when the pressure of a gas above the surface of a solution is increased? And they're doing it for us. They're pushing this down, and we are trying to figure out what happens to the pressure if the solution, when the pressure is increased. What happens to these dots when we start putting pressure on them, which means squishing them together? So let's take a look. Less gas will dissolve, more gas will dissolve, gas will become a liquid, or no change will occur. This is not necessarily intuitive right off the bat, but the thing to do here is to figure out how many of these open circles there are in both and how many of the little circles with gray. So let's count the open. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have the same number of gas molecules on both sides, even though they're pushing down on this one, same number. Now let's check the liquid molecules. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have exactly the same number of gas molecules and the same number of liquid molecules, even though they're putting more pressure. That means no change will occur. None of them dissolved, even though they were pushing them down. None of them disappeared. So there's no change.